much more inspired, especially to study. This QR code I already provided in your e-learning. If you check your e-learning, there is attendance QR code and also a group project. Before end our class today, we're going to look into what is the group project are about. And today we're going to go through our module 7. We're going to learn on latches and flip-flop. If we can finish flip-flop, it's very good, but I think it's going to take several time for us to finish on our latches, especially this one is a new thing for you because it is related to sequential circuit, the new thing. Last time we learned on combination circuit, so today we look into sequential circuit. So if you have any question, I can see that a lot of you WhatsApp me asking about the lab 1. If I did not reply, please spam. I'm not intend to ignore your WhatsApp, but there is a lot of WhatsApp, and plus last 2 weeks I'm quite busy with a workshop. I got workshops since 8 until 5 p.m. every day. So I really have time to reply all my WhatsApp and every day is increasing. So if I miss your WhatsApp, please re-WhatsApp me, spam my WhatsApp, okay? I try to reply, but sometimes I did open and I try to reply, but there's something have in the middle, so I forgot to reply. So it's going to be like read already. So I don't know whether I already replied or not. Okay. If you have any question, you can ask me directly. Here also can. And today we're going to look into our chapter. Doctor haven't accepted me into the class. I don't know what happened. This Google Meet, it is supposedly auto admit, but I need to open this, then it can automatically accept. If not, it's just hanging there. Okay, so today we're going to look into our module 7. If you have any question related to your module 3, 4, 5, and 6, you can always ask me, okay? In the middle of your class, or maybe you can also WhatsApp me. Or maybe after you finish your class, you can wait and ask me any question you want. So, last time we learned from the beginning of your digital logic subject, we learned on combination circuit. And now we have new, I think quite a new term for you, which called as sequential circuit. So what is the difference between combination circuit and sequential circuit? So sequential circuit, a big differentiation between each other is sequential circuit, it remember your previous output. Okay, this is the very first thing that you need to remember on sequential circuit. Okay, last time if you have 0, 0, 0, 1, 1, 0, 1, 1, if you have AND gate, let's say, you can directly, maybe any combinations of gate, you can just see the input. If 0, 0, what is happening? If 0, 1 is what happening. And in terms of signal or timing diagram, you can also have whatever input. But you can see, you just look into the existing input, it will occur for your output. Input, you're going to have the output. But when you have sequential circuit, you need to consider your previous output. Let's say your previous output is low. So you need to check if low, what is happened after that. If before this it is high, is it will be continue with high or it will toggle. So that is on sequential circuit. You're going to also consider your previous output. Normally in question, your initial or your previous output will be given. So you know that, okay, previous output already given, you can check the previous output, let's say Q equal to 1. So what will happen after that? Okay. Let's go through a bit on your sequential. Before that, you can see this is your combination circuit. You got input, whatever I have in your input, it will generate your output. So everything is depend on your circuit, but whatever input that given, it will trigger your output. Berlainan or different, you can see the output depend on the input only, and there is no memory element. It didn't remember your previous output. Your previous output, there is no memory at all. But it's different with your sequential circuit. It got there a memory. This is the only difference. You can see here, this is your combination circuit flow, and when you have another memory here, it's generated as a sequential circuit because your sequential circuit got a memory. What is this memory? It will remember your previous output. So that's why here, let's say the output F equal to 1. So this 1 will be stored in your memory. If the output is 0, then 0 will store at your memory, and if needed, it will push back into your circuit to generate new output. That is the difference between your sequential and combination and your combination circuit. It has memory element, and the output is depend on the input and also previous output from the feedback element. Okay, that is on your sequential circuit. You need to remember that sequential circuit can be divided into 3 categories, which is event driven, clock driven, and also pulse driven. This is only these 3, which is asynchronized, synchronized, and the combination of these synchronized and unsynchronized will make as a pulse driven. So you can see and read all the definitions for clock driven, event driven, and pulse driven. And pulse driven, you can see a combinations of your asynchronized and synchronized. While for your synchronized, which is clock driven, you can divide into cyclic and also non-cyclic. Sequential logic circuit that return back to original state once reset. A circuit with loop or feedback patch are called as cyclic in the natural. So you can read the definition there. In your sequential circuit, the very basic on it is latches and also flip-flop. Last time, you got combination logic. What is your basic? Is your gates. AND gate, NOT gate, OR gate, all the gates, when you combine it together, when you combine all the gates together, you're going to get a combination circuit. While for the circuit, sequential circuit, you're going to have all the latches when you combine it together, let's say I just give you example. So you're going to create a sequential circuit. So the basic under your combination circuit is the gate itself, while for the sequential circuit is latches and flip-flop. That is the very basic that you need to learn before you proceed to next under your sequential circuit. Now we're going to go through one by one. Latches got 3, flip-flop got 4. Latch, SR latch, this is 1. Gate SR latch, SR latch and gate SR latch is different. Although you say, SR latch, this also SRS, but when you add gate here, the name as a gate SR, it is different. So it is not same between each other. Another one is get the latch. So let's see what is SR latch, how the circuit look like, how the block diagram, what is the timing diagram, what is the truth table. All is similar to your last time. You got the combination circuit when you have like adder, marks. So you still need to have what? Block diagram, circuit, truth table, timing diagram, and etc. So similar on your latch. After your latch, you're going to look into flip-flop. Flip-flop, you have H trigger, D flip-flop, SR flip-flop, JK flip-flop, and T flip-flop. But this one, if we can cover, we try to cover. But all together, totally today, we will look on the latch. SR latch, get SR latch, and get D latch. So what is the meaning by S, R, and D? S will be your, can remember? This is your data. This is your set. This is your reset. So let's take a look. You have S to set, R as a reset, D as a data. But normally we didn't use long term of name. We just call it as SR latch, get SR latch, or get D latch. The theory about the latch that you need to know is latch is temporary storage device. That's why you can see there is a memory, right? So it is temporary only. It will store the previous output inside the memory. Last time we did see the block diagram. And it has 2 stable state, which is bistable. So all of this information, of course, is going to be asked in your part A for your final exam. Or maybe we just play around. Is this statement is correct or not? Or maybe which one is correct or which one is not correct about a latch. So maybe we just play around. Latch is 2 stable state. Then you need to say, okay, this is correct. Latch is level sensitive or level trigger, which is it is depend on voltage level applied, not on the signal transition, which is your input directly. So let's take a look example on our first SR latch. You have 2 types. Although you last time you can see, okay, latch you can divide into SR latch, get SR latch, and D SR latch. But in each SR latch, you can have high, active high, and active low input. If active high, this is a normal things that you learned last time. There is no bubble, there is no bar. This is active. And for the active low, you will have the bar here. Or you can replace this NAND. Last time, if you convert it, you're going to have also a negative O. So that's why you can draw also like this in terms of active low. So you need to know how basically it look like. Okay, next. You need to remember the circuit inside if you want to play around to prove what is the input, what is the output. But after this, you can directly remember. If let's say you have 0, 0, what is the output of Q? If your input 0, 1, what is the output? You can directly get the answer later on. But here, you have the connection. Let's say I give you example. We have the condition of 0, 1. Okay, let's say we have 0, 1. S is 0, R is 1. And I just mentioned just now, the previous or initial Q will be given in the question. So let's say Q are starting with 0. So initial Q will be 0. Our R is 1. Our S is 0. So let's check. This 0 will be putting here as a 0. 0, 0, you will get 1. Our Q bar is 1. It's directly connected to here, 0 and 0. You will get 1, 0. So this will be your next output. First output is initial 1. Second will be 0. And then if you have a different input, or maybe you just remain the same, you're going to get third input as same. But if you change, let's say it will be 0 here now as 1. 0 with 0, 1 and 0, you will get 0 here. And this will be 0, 0, 0, you will get 1. So your next will be 1 for your Q. Your Q output now is 1. When your previous Q is 0, your R is 0, your S is 1. Then you will get Q is 0. So this is just like your normal input value, you play around, you put inside, and etc. Okay. So now in terms of block diagram, why you just want to see here? Because normally when you go further, you will have the truth table, which is you need to remember. Similar to your things. For AND gate, you have the truth table, 0, 0, apa dia? What is the output? 0, 1, what is the output? 1, 0, what is the output? 1, 1, what is the output for your AND gate? So for your SR latch also, later on, you will see the truth table for it, which is you need to remember. So now this is the thing, you need to know your understanding of what is happening and why you can come up with that truth table. This is the logic symbol, like a block diagram for active high. We can see here there is no bubble, it is active high, there is no bar, it is a active high. While for the active low, you got bar here, and this is your input of bar. So this is your input S, this is input R for your active high. So set in your mind, and you got here the output of Q. And whatever value for your Q, this will be vice versa, because this is a Q bar. So you just need to generate the Q. Later on, our Q bar will be toggle. So this one is use NOR gate for your active high and also NAND gate for your active low, and the input is S and R, while for active low is S bar and R bar. The output is similar. Okay, for the truth table, let's see what is basically happened. When you have, this is the initial value or your Q previous. As mentioned, you got memory, right? This one is stored here. When you have the input of, let's say, 0, 0 for S and R, 0, 0. And then you have the memory. What is your memory? You're going to have a 0 also. So you're going to get your output of what? So you go back to this circuit just now. Okay, I draw it here so you can see it clearly. This is SR active high. Okay, just ignore the ugly one. Okay, now we're going to see one by one. First, we have S as 0, R as 0, and our previous Q is 0. Q is 0. So here will be 0 also. 0 with 0, our NOR gate will get 0, 0, 1. So 1 here will go here and it will be 1, 0. So this is our output. So you can see from previous we got 0 and now our output will be 0. Okay, understand this one. Next, alah, I delete. Macam mana nak undo? Tak boleh. Aduh, yai. Wait ah. Okay, now we have still similar, our S and R is 0, but our Q previous is 1. This is initial Q we have here, 1. We will connect to another node here, 1 and 0. This one is, I tak perlu tunjuk, no need for me to explain. This is our node. We know if it is 0, 1, our node will get 0. So Q bar is 0, it's direct connect to here, 0 and 0, you will get 1. So you can conclude, see here the output is 1. Then we can conclude if 0, 0, whether the previous is 1 or previous is 0, you can see the correlation between each other that it will follow the previous input. That's why we're going to conclude it when we have S and R 0 and 0, no change to the next output. So our output will be no change, of course Q bar also no change. No change, latch remain in a present state. The summer is going to follow your previous output. Okay, so now next, we have next condition. Kita buat satu-satu so that you can understand, okay? I can directly go to this for you to remember, but I want you to go deeper to understand and apply all the input here. Rather than you just, I said, okay, you need to remember this table for this scenario, this will be happen. But instead, you need to have the understanding how you're going to get this table. Okay, we see this scenario, which is 0, 1. 0 for our R is 1. And let's see the scenario if Q is 0 for the previous. Q is 0. 0 will be here. 1 and 0, you will get 0 here. 0 and 0, you will get the output of 1. Now your previous is 0. Your output will be, see? 0 and 0. Sekejap I check. 0, 1. Here is 0. 0 will be 0. 0 and 0 is 1. 1 will be 0. 0 and 0, you will get 0. 1. Reset. Which one that I did wrong? 0 and 1. 1 is here. Sorry. You only kan? Tak perasan This will be R. This will be S. Tengok dekat sini. This will be R. This will be S. I dah terbalik. So, here, just now, okay, because just now is 0, 0, it doesn't matter, so it's sama. But now because you can see, supposedly R here, S is here. So that's why it's different. You need to see R will be connect and the output will be Q. S will be Q bar. Just now when I did 0, 0, I didn't realize this part because 0, 0, it doesn't matter. In switch also can write because the word 0. So now S is 0, R is 1, and our output first condition is 0. When we have here 0 and 0, we will have 0 and 1. 1 will be 1 here. 1 and 1, you will get 0. So you can see previous is 0 and now is also 0. You can say that it is no change because it is 0 and 0. But you check another one. When the scenario, the input is similar, which is 1 and 0, 0 and 1 for S and R, but the previous output is 1. Previous output is 1. At your memory, you put 1. So let's check 1 and 1. You put 1 here because it's connected to another next input as 1 and 0, you will get 0. 0, you bring here 0, you will get 1, you will get 0. So you can see, oh, now it's changed from 1 to 0. But you can conclude when you have 0 and 1, 0 and 1, whatever previous output, you will remain get 0. So that's why you can conclude when S is 0, R is 1, your latch output will be reset. Reset is you're going to put 0 for your output. This one, not this one. This is Q bar. Of course, it will toggle value. So 0, 1, you will get latch as reset, or it will be 0 for your output. Whether the output, previous output is 0 or previous output is 1, you will get also similar. So that's why you can conclude like this. Next is another third scenario when you have 1, 0. Okay, we have 1 for S, 0 for R, and our previous output for our Q here. For our Q is 0. So we put here 0. Then here will be 0, 1 will be 0, 0 will be get 1. So previous is 0. You can see it changed to be 1 now. Okay, it's okay. Let's see another one. Similar input, but the previous output is different. Let's check what happened. We have 1 now. 1 will be here, 1, 1 and 1 will be 0, 0 will be 0. This one will be 1. So now it remains same, but it is 1. So you can conclude whatever input when you have S and R, 1 and 0, you will get the output of 1. Whether the previous is 1 and previous is 0, you will get 1, or we call it as set. Okay, and there is invalid input. You cannot have 1 and 1, 1 and 1, although the previous is 0 or 1. You cannot have this. That's why it is invalid condition. So why when you put, okay, when you put the value, let me try to see. One, and then we have previous output is 0, okay, let's say 0, and here we have 0, 1 and 1, we will be getting a 0. 0 will be, and here will be 0. You can see here our Q now is 0, but this is also 0. That's why you said it's invalid. You need to have vice versa, which is supposedly you can have here is 0, your Q1 will be 0, 1. If here is 1, your Q1, Q bar will be 0. So when you got 1 and 1 for this 0, you will get 0 and 0 for the output Q and Q bar. That's why it's invalid. You can see 0 and 0. Okay, so that's why you have invalid condition. So from what I explained now, you need to remember this table for active high. I already derived for you one by one, so I hope that you understand. You can just, okay lah, I don't want to understand, but you need to remember. Okay, just now I explained for you to understand how you get the output of this truth table. This is for active high. You have another condition of active low. You can try your active low. You apply into this, what we call this circuit. You apply similar thing what I did, and you will get the output of this. When you have 0, 0, just now it is no change, but for active low, you will have invalid condition. For the 0, 1, just now you reset, but for the active low, it's going to be set or 1. For the 1, 0, you will have the vice versa, which is from set. For the active high, going to be reset for the active low. And lastly, if it's 1, 1, invalid for this active low, but no change for your active low, active high and active low. So these two tables you need to remember. You can read the explanation, which is similar what I explained just now, the things that we apply one by one for the input. Okay, let's see in terms of example. In terms of example, we have SR latch, active high. This is active high. Effective low, you have the bubble things there, right? Okay, this is our active high, and I need to remember my truth table. 0, 0, no change. 0, 1, reset. 1, 0, set. And 1, 1 is invalid. Okay, previous we consider it to be 0. Normally in question it will be given, okay? Previous we consider it to be 0. Now we have 0, 1, 0, 0, 0, 0, 0, 1, 0. 0, 0, 0, 1, 0, 1, 0, 0, 0. Okay, we have here 0, 0, which is no change. That's why it's similar to your previous one. And 1, 0, 1, 0 is what? Set. That's why you will set to be 1. And 0, 0, you need to refer to previous one because it's no change from your previous. It's going to be follow the previous one. 0, 1. 0, 1 is reset. Reset is what? 0. You're going to go to 0. And now you have another one, 0, 0, which is no change. You need to check your previous one, which is similar, 0. You have 0, 1. 0, 1 is reset. So you're going to have 0. And 0, 0, no change. You check your previous output is 0. And now 1, 0, it will be set. Set will be 1. And 0, 0, no change. You check your previous one, you're going to have 1. So this is how you're going to draw your timing diagram following the input that given and through table that I asked you to remember. Okay, this is explanation from this part. Set, hold. So hold is no change. Set is, you know, a 1 there. Reset is 0. Hold is no change. So everything is putting into your timing diagram on explanation. And this is the Q value. 0, 1, 1, 0, 0, 0, 0, 1, 1. You change this into the table. Okay, next we have another example. As I mentioned in the question, you were given with the initial value of Q. And in this one, you see this part also, you already know it is active low. And it's help you another one more time, it's mentioned active low. So directly draw the table for your active low. 0, 0, invalid. 0, 1, set. 1, 0, reset. 1, 1, no change. Let me see the value. First of all, what you need to do is you need to draw the dotted line there. At every changes of the input. This question is already give and dotted line at the specific point because it's already know dekat mana which part that is going to be trigger of the changes. But before you know, you need to draw every single changes on the input. So it help you to see better clear in the value of your input. Okay, now I have done with my dotted line here. This is the first thing that I need to do. Now I'm going to draw the value 1, 0, 1, 1, 1, 0, 1, 1, 1, 1, 1, 0, 1, 0, 1. 1, 1, 1, 0, 1. 1, 1, 1, 0, 1, 0, 1, 1, 1, 1, 1. Okay, done. Let's we draw the output. The initial is 0. The initial is 0. If here is 1, 1, of course, it's invalid. And next is our 0, 1. 1, 1 is no change. 1, 1 is no change. Your previous one is 0, so it remains 0. Now you have 0 and 1. 0 and 1, it will be set. So you have like this. 1, 1 is no change, so you remain no change. 1, 0, if reset, so you have like this. And at this part, you have the small thing here, 1, 1, it's remain. from your previous because no change. Next, you have 0 and 1 is set. So you have here, and 1, 1 is remain, no change. 1, 0 will be reset. Oops. 1, 1 will be remain. From here, 1, 0, it will be reset. And 1, 1, it will be similar, no change. 1, 0 is reset. 1, 1 will be remain, following the previous output. And 0, 1 will be set. 1, 1 will be no change. And 0, 1 will be set again. And 1, 1 follow your previous output. So this is your output from the timing diagram given. So let's see in terms of like very beautiful timing diagram. This is your answer. So by using that thing, see, this is the thing that I showed you just now. I need to have also in between, which is no change, which is you have 1 and 1. That's why I draw all the dotted line at each changes between my S and R. So here is the similar thing what I did just now. Next, do you have any question? Any question related to this SR latch? Any question?
No, doctor.
No, okay. So I'm going to move to next. We have now the get SR latch. Before this, you have only two input. That's why you have like quite easy things because you just refer to the two input. You need to have the basic understanding, but when you go for your get latch, you have another one more input we call as enable input or EN. It is like a switch, which is when you enable it, when you click on, which is normally click on, which is 1, right? And then it will turn on. If it is 0, it will turn off. So if turn off, of course, nothing happen. If it is 0, nothing will be happen. If it is 1, it will look into, if 1, it will look into your input of S and R. Okay, now what is the difference is, you can see here, you have another input called SEN. Just now you don't have this for SR latch, but now for get SR latch, you have another this input called EN. And this is the circuit. A circuit for our get latch, active high, and then here is active low. So what is basically here, this one, if you can see, this is your SR latch. When you combine with another combination of this, you get SR latch. SR latch, which is, okay, this one is for active low. You can see there is a bubble things. Okay, it is not too hard for you to remember. It is basically similar. You can see here. This is similar to your SR latch. The difference only, you need to look into your enable. When 0, nothing happen with each, no changes. When you have input N as 1, you need to refer to SR, input, which is similar output for your active, high, SR less than. 0, 0, no change, 0, 1, reset, 1, 0, set, 1, 1, invalid. So let's take a look in the example here. Just now what I asked you to do, I asked you to draw the dotted line. Although maybe you already advanced, doctor, I'm going to draw the dotted at only E and S1 because I know only at S1 it will trigger something. But because we just beginner, let we draw every single changes that happen here at our input. So just ignore my ugly drawing there. Okay. So we have here, that is the first thing you need to do, the dotted line. Second, put the value of each 0, 1, 1, 1, 0, 1, 0. Kalau I salah, please inform me, okay? 1, 1, 0, 0, 1. Here will be 0, 0, 0, 0, 1, 1, 1, 0, 0, 1, 0. And our end here 0, 0, 1, 0, 0, 0, 0, 1, 1, 1. Now my turn to draw. As mentioned in our table, we got here E, N, S, and R. If it is 0, nothing happen, no change for our Q. And then we have 1, 1, 1, 1. If we have N for EN as 1, our SR 0, 0, no change, 0, 1 will be reset. Our 1, 0 will be set and 1, 1 will be invalid. Okay, follow our table here. We got, because this is SR latch, get SR latch active. Then we have the initial value of low. Low, 0 here means no change from previous. It will be remain 0. 0 here, no change. It will remain 0. Then we have 1. What happens if we have 1 for our N? We need to refer to our SR input. S1, R1, we will get 1. So that's why we will get 1 here. Stop at this part. We have 0 for the input N. Then input N, if 0, nothing happen, no change, we will keep remain 1. Again, we meet another 0, it will remain 0 here, 1 here because no change. So next we meet 1. If we meet 1, we're going to look into our input. Our input now is 0, 1. Means that it's going to be reset or 0. So it will be reset. Now we meet with 0, which is no change, 0, no change, and 1 here. We will look into our input. Our input is 1, 0. Will be 1 or a set. So it will be 1. Next, we have another one. So we need to look into our input here, 0, 1, it will be 0. Our n is 1, we need to refer to the input, which is 1, 0, it will be set. So this is how we draw our output. Any question? Look into the beautiful side. If you compare to mine, it's quite ugly. So this is our final answer. Is it hard or not? So by referring the table that you need to remember, you can generate your output or timing diagram output. Okay, let's take a look another example. This one is very helpful because it's already have the dotted line. I just need to remember the table. My table is EN SR output 0, no change, no change, no change. 1 1 1 1 0 0 0 1 1 0 1 1 0 0, no change. 0 1 will be reset, or 1 or 0 set and invalid. So from this table, I got here another hint, Q initial as low. So let me try to draw my output. Before that, I already have dotted line. Second, the input value. So here will be 1 0 0 0 0 1 1 1 1 0 0 1 1 1 1 0 0 0 0 0 1 1 1 1 0 0 0 0 1 1 0 0 0 0 1 1 1 1. And another one is our n, 0 0 1 0 0 1 1 0 0 0 0 0 1 0 1 0 1 1 1. So I'm going to begin my drawing. First, I need to remember initial is low. So I check my n first, En. It is 0. What will happen? No change. No change. I'm going to continue. Another one, I meet 0 again, no change. And now I meet 1. I need to check my input. Input is 0, 1, which is reset. Reset, so it will be 0 also. 0 and 0, no change, no change until I meet 1 here. I need to refer to my input. I have 1 0. 1 0 is what? Set as a 1. I have another 1 here. I need to check my input. Similar 1 0. I'm going to have 1. And 0 0 0 0 0. No change, no change, no change, no change, no change. Until I meet 1 again, what I need to do, I need to refer to my input. My input is 1, so it will be remain as 1. And then I meet a 0, no change. Now I have 1 here. Mine is similar, which is 1. And 0 will be no change. I meet 1 here. I need to check my input. So the input is all similar for this one, this one, this one, which is 0, 1. Will be as a reset. So I have like this. So I get like 5 marks for this question, or maybe 3, or maybe 4. It depends on how many changes you need to make. So let's see the answer. So similar, right? cumai. So this is the final answer. We just need to plug in the value from the truth table, from the table here, plug in into the answer. So here you have the similar things, but it is in terms of table. Just now you have in terms of timing diagram. Now we change a bit. We look into the table. From this table, what you can see, you have the initial value of Q. You were given with the value of input and output. These Y and Z, you can directly use your NAND things, which is if N is 0, S is 0, R is 0, 0, 0, your NAND gate will get, let's say, 1. 0, 0, your NAND gate will get 1. So here will be 1, 1. So at this Y and Z, you can follow that method. But for your Q, this one is totally for your, what we can say, your gate SR latch. So this output can be used using your table just now. For EN, SR, output 0, nothing happened, it will be no change. 1, 1, 1, 1, 0, 0, no change. 0, 1, reset. 1, 0, set. And 1, 1, invalid. So let's take a look. Previous is 0. If it is 0, 0, 0, no change. 0, 0, 0, 0, no change at all. Until this one. When you have the input of 1, 1, 1, 1, you're going to consider your input, right? So if it is 0, 0, what you will get? You will get nothing change from your initial value. And then 0, 1, you will get 0 also from here. 1, 0, you will get 1, and 1, 1, you're going to get invalid. So this is the table.
So doctor, do we write 0 for invalid in that
Okay,
truth
this
table?
one is active flow. Wait, the question is, oh, you have, kenapa dia tukar? Why it's changed? This now is, okay, the question for you is for the active flow. Sorry, so the table just now is different. Okay, what is your question?
For invalid, do we write in the truth table 0 or X?
Okay, you're going to write like this. This one is from the combination circuit, but you will mark it as invalid because you cannot get Q as 1 and Q bar as 1 also. It is invalid. Although you get Q, your Q bar, if you have another table here, for Q bar is also 1. So you will set it as invalid. The output, when you write here, you can write 1. And Q bar, you will like 1, 1, 1, 1, 1, 1, 0, 1. Here you will get 1 and 1. You just write here, but you mention it is invalid. Okay. So this is how, just now I show you active high, sorry, because I see this, I didn't refer at this circuit just now. So supposedly it is active low. For active low, our table is slightly different, right? So this will be S bar, R bar, and your output will be look like this using your active low table. So any question before we move to another latch? So our final latch is our get the latch. Okay, this is get the latch. Basically, the difference between the rest is the latch, get the latch only have one input there for the input. But of course, you're going to have the enable switch there, EN. And it is basically similar to your SR latch, but with the input of, okay, let me draw carefully. Yeah. This is your SR latch. When you add this one, you will have get SR latch. And when you add another knot there, this is another knot, you're going to have get D latch. In the proper way, you can see like this. This is your SR latch. This is your get SR latch when you add this part to your SR latch. And when you add another knot here all together is your get D latch. So this is the correlation between each other. And it's much more simple because you need to remember only this thing, I guess. Because for 0, 0, you know already, and 0, there is no changes at all. So there is no changes, right, if it is 0 and 0. But for 1, for input N is 1, you need to check your input D. If it is 0, your output will be similar as a 0. If it is 1, your output will be 1. Or we call it as a reset and also set. So only that thing that you need to remember, I guess, is very simple. So in terms of the combination circuit, you can remember this, but normally it's going to ask you about the timing diagram, about the tables, the output. Okay, if we have like this, first of all, I mentioned draw the dotted line first. Wait, I draw first. Every single changes, please draw the dotted line. Okay, I done for my first step. Second, I need to put the value 0, 1, 1, 1, 0, 0, 1, 1, 1, 0, 0, H, 1, 0, 0. And my end here 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0. Okay, done. So I try to draw. Before I draw, I need to remember EN and D. 0, nothing happened, nothing changed. If 1, 1, 0 and 1, our Q will be 0, our Q will be 1. So let's we see. If 0, 0, nothing changed, our initial is low. No change, no change, and then we meet 1. 1 we refer to D. It will follow our D as a 1. No change, no change, no change, no change, and we meet our 1 here. We refer to our D. It is 0. So we put 0. No change, no change. Until we meet 1, we refer to the D. The value is 1 there. No change, no change, no change, no change. It's going to be until up here. And we have 1, we refer to our D, it will be 0. 1 will be referred to the D, we'll be having 1. 1 we refer to our D, it will be 0. 1 we refer to our D, it will be 1. 1 will be referred to our D, it will be 0. So this is our output from our get D latch. Easy, right? So this is the output. Same, but not in the quality of drawing. So that is the thing only that you need to know on your SR latch. Get SR latch, and also your get D latch. So you have only 3 latch that you need to remember. Any question? If no more question, we just go through what we're going to learn tomorrow under flip-flop. We will look into SR, H, trigger D, JK, and T. What is all this about? So for first one, we're going to look into SR. Before that, you need to know the function of flip-flop. When you're going to have the flip-flop, there is a keyword for flip-flop. You need to have clock. So you have several trigger, positive, which is rising edge, and also falling edge. Tomorrow we look into this, and you can see rising edge is positive edge, falling edge is a negative edge. And you can see this is last time I give you some hint. There is a clock. You will learn on this thing. When you have from low to high, you have the arrow like this. It called as a positive or rising edge. And you're going to have a negative one. You're not going to have this arrow like this, because your wave will be moving from left to right. So you cannot have vice versa. That's why your falling edge or your negative clocks, negative pulse, you're going to have from high to low. Although this one is high to low, but you cannot move to the left, right. You need to move to the right. So that's why this is your negative going pulse. And the differentiation for the symbol, for negative, you're going to have this bubble at your clock. This is the symbol for your clock. Okay, what else you're going to look? Flip-flop, there is a lot. Compared to your latch, you have only few input. But for your flip-flop, you can see you have SR, you have the clock here. Sometimes you're going to have also the set, you have input, what else, set, reset. Later on, you're going to have a lot of input. Here, 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 here. So all the input on your flip-flop. But we will go through one by one. That's why you will learn from latch first, and then after that for your flip-flop. So although you can see this is a flip-flop for your SR flip-flop, you have the S, you have the R, and you have the clock. It is similar to your EN. You're going to only change when you have the value of 1, right, for your N. But for your clock, you're going to change only whether at this side or this side. Whether at this side or this side. So at this side or this side. So you have two sides that you need to consider for the clock. What else? There is also truth table that you need to see. You can see here just now if you have EN. If you have EN, the switch of EN, you have whether it is 0 or a 1. But now you can see the clock here is falling, rising up or either falling down. So now the clock is all rising up because you have the positive clock. So that's why your changes at this specific rising up. If let's say you have the negative, which is bubble here, falling down, your changes or trigger will be at this point. Going to change at this point, something like this. So now your changes is at the rising up for the positive. So tomorrow you will look into all of this. And you have the JK flip-flop also. 4 things that you need to remember. See here the thing that I said. Later on you're going to have another input to be considered. So in terms of priority, which one that you need to see first? Just now you have the get SR latch. What you need to consider first? The EN, right? But later on in your flip-flop, you need to also consider the pre and clear. First, look into pre and clear. If maybe you have the EN second, and then maybe for the clock is third, and then after that you look into the J and K. So all the priority we will learn together tomorrow. Okay, see? The highest priority is pre and clear first. Second, baru you're going to look into the clock. Lastly, you're going to look into the input of your SR, JK, DOT. So there is a things that you need to remember. There is a lot of 1, 2, 3, 4, 5 input, but your output will be remain only 1 for the Q, and you got the bar over there. For every single thing, maybe later on you will play around a lot in terms of timing diagram. So play around with timing diagram. Last time for your module 1 until your module 6, you play around with your Boolean expression, you play around with your K-map, you play around, yeah, all about your Boolean expression. But not, you play around with your table, truth table. So now you mostly look into the timing diagram. How the timing diagram, what is the output will be generated. Okay. So that's all for your module 7. We're going to finish tomorrow, and as soon as possible our module 7 finish. We're going to directly go for module 8 because we have your project, group project. Mana I punya e-learning? Okay, this one. we have group project. Let me open using my slide. Okay, you have this thing in your e-learning. I already provided. We will do our group project. You need to use and follow the exact group that I already created last time for your lab. Okay, this project is created by Dr. Fuad and Dr. Ismail Fauzi, and this will be similar from our section 1 until section 10. I forgot already, or 15. Altogether, for digital logic subject, our semester will be using this similar project. You need to do within 3 or 4. I do believe some of you got 5 in your group, but it's okay as long as it is under your lab group. And there will be step by step how you're going to do your project. Why I give you now, although you still not yet finish your module 8, you need to start from now. From part A, you have a part A. This one you already done. From your combination logic, you have the comparator, pattern detector, decoder, marks, and etc. And you have, if let's say you want to add extra features, also can. For part B, there is the things that we just learned today and tomorrow, and we're going to finish it also. That is on the sequential logic. And after that, we're going to do the integration part. This is the thing. Sometimes you wonder where you're going to apply your digital logic, whether you just want to convert it to our machine language, which is 1010. But basically, digital logic have a lot of things that can be connected or relate to our daily activities. Example on our real life, which is our lift or elevator, which is using our digital logic system. Photostat machine also using a digital logic. Car park, vending machine, and ATM all are applied using DL only. So you can see now, someone that view the ATM is basically someone that already learned digital logic and just using this digital logic. And also maybe for the security, for the network, it is different, not a cover. But when you have digital logic, you can have the ATM machine. So just figure out how digital logic can help you in terms of your real life. And you need to play around with the input, process, and output. So what you need to do now, you need to meet your group. You need to discuss which topic that you want to use to do. So you can see, you may choose any system you want to design the controller and study how the system works. Example, okay, this one example on the lift. So you need to start now, select whatever situation which is from this example. You can have much more maybe. And when you select, you need to find the reference. You can go for Google. There is a lot of similar project, I think so. From there, you need to come out with your own scenario. This is your scenario. You are the one to create. Maybe you already determined for the elevator, you have 7 flow. So you set only for 7 flow. You are the one that need to consider for this scenario. And what will be considered for the lift? Let's say for the key level up, you have button, right? Ground floor, 1, 2, 3. So all this button you can set by yourself. Let's say 3 is 101, 4 is 100. I just give you example. And then let's say 5 is 101. Okay, this one is 11. So this thing you need to write in your report because you are the one who set. Okay, and maybe you have the card hotel. So the card hotel, there is a name, maybe a number of 101. Room number is 101. It will be go directly to level 7. So you need to have the consideration of scenario from ground floor. It will go to the level 7 if this card is 7. If the card is 6, it will go to the 6. If the card is 5, it will go to the 5. So it will be bigger. Okay, you cannot see only 1 or 2 scenario for the input. And then when you're going to decide the door close, so of course you have the button of close and open. And lift goes out to the destination, lift stop, and etc. So this is the condition you need to discuss with your team member. This is example from the circuit. You have the comparator here. Maybe you're going to compare when you have from level 1, you want to go for level 7. So you already press in the button at your lift 7. But when you go up, you're going to check one by one. This is level 2. Is it similar or not with level 7? This is level 3. Is it similar to not or? And this is all under comparator. So at this one, this is your extra. You can display your 7-segment display, whether it is at the level 7 or maybe level 5, level 3. So you need to design it carefully. For the part A, you can start now. Part B, you still need to learn some more. And then you're going to integrate. So what you need to do is, this is the format report. You need to have time Roman 12 font, 1.5 spacing. Of course, this one grammar. So you need to have title page, acknowledgement, dedication, table of content, report content, references. This is the things that you need to Google. Google and find reference. You need to cite your references. And if you have appendix, because maybe you have a lot of picture that you are snap using your mana berzi, using your DIT simulator. So you need to screenshot or maybe you save your DIT simulator picture. We're going to put in your report, or maybe there is a lot, you can like appendix, you put in the extra picture in your appendix. So project content, what you need to include, and you need to use this drawing. Okay, you cannot draw your circuit using your pen. What else? Words, whatever tool for drawing you cannot use unless it is a DIT simulator. And lastly, of course, the demo of your report. When you have all the combination of the circuit, you need to demo and explain on how it's going to be run. So when we're going to submit later on, after we already get, I guess, on the confirmation about your academic calendar, last time we did extend 1 week, right? But it's not yet officially announced by Senate. So when it announced, we're going to decide when we're going to submit. Normally, I'm going to do the submission for your study week before final exam. Okay, any question? Any question related to your project, related to your module? Okay.
What about the groups though, Doctor? Like, are we gonna have new groups again?
No. I mentioned already, you need to follow your lab group that I assigned last time.
Okay.
Okay.
So, doctor, what is the process? Like, in this example, what is the process? Is it the switches and stuff, or
Again, what is the
what is
process?
the process? Yeah, it's input, process, and output.
Okay, wait. You need to decide which one that you want to do. So there is a lot of project that you can do. From here, let's say for your ATM machine. If let's say you press, mana I punya drawing? Okay, I give you example of traffic light. Traffic light. If you have the stage of, let's say, red, you assign red to be, let's say, 0, 0 at this stage of 0, 0. If it green, it is like 0, 1. If it yellow, it will be 1, 1. And the red, 1, 0. And 1, 1 is maybe don't care. So this scenario, if you still remember module 4, problem statement. Problem statement similar to your lab 2. You need to decide your own input. You are the one to set red is what, green is what condition that you have. Similar also ATM. You have, let's say, the keypad of 0, 1, 2, 3, 4, 5, 6, 7, 8. And then you have another button there. If you don't want to put button also can. It's depend on you because you are the one who create the scenario. But of course the scenario will be a real one. If ATM supposedly, let's say it have what? Accept, cancel. So all these button you need to assign with the input. So let's say you said 0, 0 is considered as 0, 0, 0, 1, 0, 0, 0. 1 will be 0, 0, 0, 0, 1. So from here, you need to create, let's say, comparator. You have the input. How many input you have? And then your output is, let's say, cannot withdraw. Let's say you tak cukup duit, your money is not enough, cannot withdraw, or maybe success. This is your output. You are the one who create your output. Let's say 2 output. And the input side, you need to decide also which one. Okay, so you have several, like maybe you can use a mark, maybe you can use a comparator. The comparator just now you can use, as I mentioned, at the leaf. If let's say you are currently at level 7, you compare with your input. Let's say your input is 1001, let's say, but your level 7 you already set. Level 7 is 1111. Example, okay? So is it more or less or equal? So from here, if it equals, so it stop. So it stop and then it open the door. So all of these will be your output. All of this is your input level and your existing leaf movement is all input. So you need to see the real condition, what is happened. You can see a lot of things that you need to consider. 1, 2, 3, 4, 5, 6, 7. This is what? Is this output? Is this input or output? So here is the things that you need to decide. You need to see the very clear of the output and then you can decide. Later on you can see you have like 3-bit switches. This is the one at your leaf. At your leaf, right? You have button there. And is in this question you can see at level building only. So this level also you are the one who decide. We just give you a scenario. You can pick any one. You can see you can choose any system. That's why in this example it have 3-bit switches only, because you can see n to the power of 3 you get 8. That's why maybe it's okay at this question you have level 1. This side is to be 0, 0, 0. Level 2, it is 0, 0, 0, 1. Level 3, it is 0, 1, 0. Level 7, 1, 8. Level 8, last is going to be 1, 1, 1. So all of this you can see you have 3 switch. That's why you use 3 switch. If there is 0, 0, 1 here, then it will what? But from this 3 switch is connected to 1 switch at your leaf. 1, 2, level 2, level 3, level 4, level 5 until level 7. So user just press this, but in term your circuit, it will connect it to your 3-bit switches. So 7, it will get 1, 1, 0, let's say. So it will connect to your display. It will put like this. So in term of this one, 1, 1, 0, how are you going to define to make this on? And this is your comparator. Why you need comparator? Because you need to check. Let's say now is level 2, but you want to go to level 7. If let's say it more than 7, maybe it's going to go down. So that's why you need to decide whether it is more than 7 or less than 7. If less than 7, it's going to go up your leaf, isn't it? If it is 7, which is similar to 7, what is going to do? It's going to stop. So this is comparator that you need. More than you need to, if more, then you need to turn down your leaf. Your leaf will be moving down. If it less, your leaf will be go up 1 step. And then it's similar, it's going to stop and open your door. So that is the example that you can see basically the real situation, what is happening. Okay, so that is like extra. This one is just a features for you to add extra, which is sometimes there is a leaf that did not have 7 segment display, right? If let's say you want to go for 2, 8, 4, 16 level, let's say. So you need to have 2 display. So it is depend on you on the scenario. Understand or not? So that's why you need to start from now. Find your scenario before you can go further. You need to find the scenario. You Google what scenario that happened that relate to your digital logic subject, which is include your combination logic and also sequential logic. Any question? Maybe sequential you cannot see now because it is just new. But when you play around with counter, maybe in terms of machine, photostat machine, let's say you count, you already said you want to have the copy, you want to have a copy of 5. So you will count when you have the output 1, and then you can count 1. Count 2, what is the output already? So you have the memory, how many you already print. So that is all on thing that you have a memory. So you need to relate. First of all, as I mentioned, discuss with your friend, find what scenario that you want to do, and you need to come out with the scenario. Move up, move down. Although it is just a leaf, you can see a lot of things that you need to consider. When you're going to open, when it's going to close. If it move up, what is going to consider? Leaf goes to up to the destination. Of course, it's going from down to up. That's why you need a comparator. A leaf stop at the destination when you equal the leaf equal to, like, let's say you want to go for 7 and then you reach at the 7, it's equal already, so you're going to stop. And then maybe this one is just extra features if you want to play with the sound. Tag hotel is also another features that you can add on, because it is depend on, sometimes there is a leaf ask you a cut hotel, but sometimes it's just a press manual button, isn't it? So it's depend on you to create the scenario. This scenario is you decide. Okay, any question? So first thing first, go and meet your groups, discuss what scenario, search online, so search Google and save all the things that you search as a references. Okay. So if there is no more question, we're going to stop our class. We're going to meet again tomorrow at 10 a.m., isn't it? Yeah. Okay. Don't forget, we're going to have our test 2 at 8, which is this coming Saturday. It's going to cover part module 3 and 4. 3 and 4, right? And it's require you part A and part B. Part A, part B. Part A will be multiple choice. Part B will be your subjective. You need to have scanner, or maybe you just snap using mobile apps, and you need to convert to PDF, upload back again to your e-learning. Total number of question, the duration, we will confirm back later on, because we're going to have a vet on 4th January. Okay, after we already vet the question, then we will inform the format to you via your Telegram. And then don't forget, similar to your test 1, you need to submit 2 forms. So please make sure you always check your Telegram. You need to update your internet connection form. And another one is what form? I forgot already. So there is 2. So you need to submit 2 and pick your correct section. Don't just simply pick my name, okay? Because I teach 3 sections. So if there is no more question, for those who coming late, you can scan your QR code available at your e-learning. And for the rest, stay safe and bye-bye. See you again tomorrow.
Thank you, Doctor.
Thank you, Doctor.
Okay, bye-bye.
Thank you, Doctor.
Thank you, Doctor.